discussed the organic Rehm reaction, Reimer Tiemann reaction. In this reaction, the substrate is mainly aromatic alcohol, that is phenol. If we treated phenol in presence of chloroform and sodium hydroxide or chloroform and potassium hydroxide, we will get the orthohydroxybenzylaldehyde, that is salicylaldehyde, and para-hydroxybenzylaldehyde. Let us see the mechanism of this reaction. In this reaction, the electrophile is dichlorocarbene and the nucleophile is phenoxide ion. Now, how the dichlorocarbene will generate and how the phenoxide ion will generate. First of all, hydroxyl ion pick up the acidic hydrogen of the chloroform, and then one chlorine atom leave, and we will get dichlorocarbene. This is the dichlorocarbene. It is the electrophile of this reaction. And in basic condition, acidic hydrogen of the phenol will pick up by the OH minus ion, and we get the phenoxide ion. Let us see the mechanism of this reaction. It is the phenoxide ion and it is the nucleophile of this reaction. Nucleophile of this reaction. Now, we know that any electron donating group will ortho-para oriented, and hence we get the ortho and para product, that is orthohydroxybenzaldehyde and para-hydroxybenzaldehyde. Since the lone pair of OH minus ion only oriented ortho and para position by the resonance. Phenoxide ion, this is nucleophile of this reaction, and dichlorocarbene, this is electrophile in this reaction. What will happen? Now, OH minus will carbon will get negative charge. This is unstable. This is unstable because the system will lose its aromaticity. And hence, to get the aromaticity, here one hydrogen remains, this will fall up and this system will get its aromaticity. This hydrogen resides this carbon atom, and hence we get this product. Since any base is soluble in water and hence in medium some water is present, this water will attack here and this chlorine will leave. What we will get? We get this type of product. Then OH minus will attack and chlorine will leave it. Since the system is basic and hence here if we use the sodium base or potassium base, if we use the base as a sodium, then we will get sodium. If we use potassium, then we will get potassium. Then if we work up, then we will get this ultimate our desired product. What we will get? We will get orthohydroxy benzaldehyde, that is salicyldate. Similarly, we get only the ortho product because the ortho carbon will attack the dichlorocarbon. If we attack by the para carbon, then we will get the para product. Let us see the mechanism of this reaction. Please remember, since any electron donating group ortho and para oriented, and hence we get the two product ortho and para. Similarly, this carbon will get negative charge. This system is unstable because the system lost its aromaticity, and hence to get the aromaticity, this hydrogen will fall off here and the system will get aromaticity. What will you get? This hydrogen will fall off here. What we get? As you know, since the system is basic, some amount of water is present. The lone pair of oxygen will attack and the chlorine will leave. And what we get? Then this OH minus will attack and chlorine will leave. What will get? Since the system is basic and hence there is no acidic hydrogen, and hence if we work up this system, we will get the para hydroxybenzaldehyde. Ultimately, if we treat phenol in presence of chloroform and any alkaline hydroxide, we will get the orthohydroxybenzaldehyde and parahydroxybenzaldehyde. Let us now write down. Chloroform, sodium hydroxide or potassium hydroxide, then work up. What we will get? Orthohydroxybenzaldehyde and parahydroxybenzaldehyde. This is the fundamental discussion of the Reimer Tiemann reaction. Next video we will discuss about Reimer Tiemann reaction.